so it's hard to see. It does look like, he had a master's student who worked on this a couple of years ago, it does look like the Mount Sheridan Gabbro, that Roosevelt Gabbro that's beneath Mount Sheridan, is a complete package. In other words, it gets a little more felsic as you get to the top, and the top of it is pretty much the top of that pluton. So again, that speaks to the opportunity that maybe the Roosevelt Gabbros, these hydrous Gabbros, are either simultaneous or a little bit later than the Mount Scott Granite, but maybe not so late that they're going to be strongly resolvable with geochronology. Oh, I'm sorry, I forgot. It's in the guidebook, though. I did cite him.
What is the, do you know the age of the argon dating? What exactly the age?
Oh, you would ask me the numbers. They're in the guidebook. Yeah, 533 and 534, something like that. 535.
For the Gabbro and the rhyolite the same, within error, the same age?
Yeah, not within error, just outside of error. So I can't remember what the error is on that, but it's just outside of error. Bill would say, yeah, clearly the Gabbro is younger, based on his analysis. I'm still on the fence about that. I would say we definitely have strong evidence that they're contemporaneous.
Steel hands at Auburn?
Yes, that's correct.
That's a matter
The Roosevelt
ongoing.
is also isotopically, possibly co-magmatic with the basalts.
Sorry, I didn't catch that.
The Roosevelt is also isotopically possible as co-magmatic with the basalt further west.
Yeah, the Navajo basalt spillite group, there's similarities between the isotopes of that and the Roosevelt Gabbros in general. They're not quite identical rocks in the nature of their composition, but there's strong evidence they might be related to one another, like Paxton. Navajo basalt spillite group. Navajo Mountains, thank you. So those again, and this came up yesterday that, you know, there isn't much basalt shown in the Wichitas. Well, it's all in the subsurface, much like we saw it on the Arbuckles, and Bob was talking about in the Arbuckles. You find the basalts in the subsurface, but they're not preserved at the surface at all. So we see the Gabbros, we see the rhyolites, we see the granites, largely bimodal again, although there's an intermediate rock further west, but largely bimodal magmatic, but nonetheless no basalts at the surface, except for talking about the diabases that go through the rocks. As you move further to the south, you get into this area called Jed Flat. It's largely covered with a Permian unit called the Post Oak Conglomerate, which Richard mentioned. And there is an unconformity preserved, we'll go look at it later, between the Permian surface and the underlying granite at the locality we'll look at. But basically, the Post Oak Conglomerate is made up of different facies depending on where you are in the Wichita Mountains. They're locally derived granite, rhyolite cobbles that are in our Cosic matrix. It's matrix supported at least here. And it is, again, evidence that we had weathering of this area in the Permian. It's being eroded into now. Underneath it, and obscured by much of it, is the Rush Lake Granite again, the same thing that's over in Medicine Park. One of these other bodies that doesn't have the ovoid feldspars, but looks and acts a lot like the Mount Scott, and is very comparable in its geochemistry. And then down in the valley there, we start into a very thin sliver of the Carlton rhyolite. That's the valley of Little Medicine Creek cutting through there. It sort of bifurcates. So the deeper part of the valley will encounter the Carlton rhyolite again. It's metamorphosed there, but still very definitively the Carlton. And then as you sweep away, you get back into the Mount Scott Granite again. Continuous Mount Scott Granite all the way that you can see from this point onward. It takes a break, and you run into the GMLC that's exposed at the surface, largely covered by Permian sediments. And then it crops out again another 20 kilometers to the west, just south of Lake Tom Steed. So 55 kilometers of this stuff. And certainly flat-lying bases that can be seen on this contact, but if you go further west, you can see that same flat-lying base between the GMLC and the Mount Scott Granite, and the GMLC is demonstrably an older unit than these Roosevelt Gabbros. Last thing I'll point out too is up to the north, you could still see Mount Scott Granite, but if you look to the furthest sort of exposures of these hills that are going out there, you see a double peak out there. That's Saddle Mountain, and that's the fourth granite that belongs with this collection of the Medicine Park and the Rush Lake and the Mount Scott. Unlike the Rush Lake and the Medicine Park, it probably evolved very late in the granite history. This is mostly Charles's work on a previous guidebook, the 86 guidebook, looking at the spherulitic textures that grade out of that particular unit. You basically can't see a definitive change, but it grades into a spherulitic texture, indicating that the Mount Scott was probably very near the surface or at the surface at that position. So, and then you get into the windmill-covered hills of the Slick Hills, but we'll walk around that way to go look at them.
John, do you want to point out where Ketone Overlook is? Because you can see some of those canyons.
Right, so if you follow the road, that's Highway 49, where it intersects that canyon system. It doesn't look like much of a canyon, but you go past this landform in front, which is Mount Scott's Boy, straight ahead. You're at that canyon area there, that's the area around Ketone Point. And you can actually see a parking lot if you look really hard, where 49 almost disappears out of view on Jed Flat. So we'll go there later today and look at some of the confusing geology there.
Maybe you said that, I missed it. What forms the valleys? Is there normal faulting here?
Oh, that's a good question. We can address some of that at Ketone on whether we're dealing with faulting that's offsetting the rocks or whether these are igneous contacts. There's lots of lineations going through here. Certainly any of the thick soils you get on the granite are these tree lines through here. Whether there's offset on those is not demonstrable.
Are you
on
sure
most places.
those could be diabase dikes that are tree lined like that?
No, I've walked around most of these. I'm hard pressed to see like some of these smaller ones are demonstrably not diabase dikes. You could argue some of the.
Do you ever see outcrop in them?
Oh, it's rare that you see outcrop in them because they're soil covered. That's where the trees are there.
That's
Every
what I'm
now and
wondering,
then there'll
if it's
be a
not
prospect.
dikes, because there's no outcrop.
Well, and at Ketone we'll see this as well, that the diabase dikes that are exposed there are basically fill trenches and highly weathered rock where it's exposed. So it's a good argument. They could be diabase dikes. Dave Stearns did an analysis in the 86 guidebook of the trends of these linears, and they're fairly consistent in their pattern. So they do point to a stress field, but whether it's a Pennsylvanian stress field or a Cambrian stress field, I don't think has been resolved.
I think if you took a good magnetometer, you could tell.
No kidding, right?
I think you'd be right about that.
It's a neat idea. But you know, Saddle Mountain, doesn't that grade into rhyolite?
Yeah, so it's spherulitic. Yeah, you could
But
call
if
it
you
a.
get up in hand sample, it's a rhyolite. It's got an aphanitic ground mass, right?
Well, it's fine grained, and I really haven't looked at those rocks in a long time, so I couldn't make a strong argument that it's definitely a granite. But it's certainly gradational from the Mount Scott. You go further south, and you're in what looks like Mount Scott. You go further north, and you're in what looks like a rhyolite or a very spherulitic granite. So that rhyolite might be the right term for it. I would agree with that.
Well, I mean, I saw that in maybe '76, and I walked that transition to go from the Mount Scott to a porphyritic granite with a granophyritic ground mass.
Right.
And to me, it looked like it graded right into what looks like Carlton rhyolite. I mean, with an aphanitic ground.
It has a different chemistry from the Carlton.
Well, I know, but I mean texturally.
But yeah, texturally, no. I agree with you. It's becoming surface or near surface.
Yeah, but how do you get this sheet of granite right at the surface and it doesn't go explosive at all?
Well, it's not very volatile. I mean, we don't have a high water content, so there might be an opportunity for some explosive volcanism, but it would be minimal,
Yeah,
I would think.
I've always just been puzzled by it. Puzzled.
There's lots of puzzles. Shall we move?
Yeah, it's just.
Stan, I'm going to